Unit 11 has to do with radicals. Radicals are square roots, cube roots, fourth roots, any kind of root that we're taking. It's just another word for root. Today, what we're going to just be doing is multiplying the radicals together. So we're just going to take two or more radicals and multiply them together and simplifying them. So we're going to have to simplify them as well, which we've actually already started. So the steps to multiplying radicals, let me give you those first. First, you are going to multiply the outside of the radicals. So if there's a number on the outside of the radical, you're going to multiply those first. Then the nice thing about radicals is you get to multiply whatever's inside first. So you're going to multiply the inside of the radicals. That's step 2. And then step 3, which is almost always our step 3, you want to simplify the radical. Which means if there's any perfect squares, you get them out of there and make the inside as small as possible. So let's look at example 1. Example 1 and 2 and 3 are just simplifying the radicals, so we're going to practice simplifying again. So remember, this is the square root of 200, but we can simplify that a little bit more. How can I simplify square root of 200? Are there any perfect squares in there? 100 times 10 is not 200.
Oh, 102.
4 and 50 work, but 25 and 40. But we can make it a little simpler. Somebody was right with 100. 100 times 2. The other ways, 4 and 50 and 25 and 8 do work, but you'd have to simplify it even more later. So 100, what's the square root of 100? 10. So this is the same as 10 root. What's left inside? 2. Okay? That's the answer. That's all we have to do. What if I had split it up 25 and 8? So this would have been square root of 25 times 8. What's the square root of 25? 5. So this would have been 5 root 8. But can I simplify square root of 8 some more? Yeah, it breaks down to what? 4 and 2. So this would be 5 times 4 times 2. And what's the square root of 4? 2. And 2 times 5 is 10. So it would still be 10 root 2. Okay? So what your goal is kind of to use the biggest perfect square possible, so that way you know it's a simplified. But make sure you double check. We know you can't take the square root of 2 because you can't break it down anymore. So that's how we know where to stop. Okay? So even if you use different combinations, you will still get the same answer if you are paying attention to what you're doing. Okay, example 2, square root or negative square root of 80. How can I break down 80 using a perfect square? 4 and 20 works.
Well, 4 and
5 and 40.
8 and 10.
8 and 10, but neither of those are perfect squares.
2 and 40.
2 and 40, but neither of those are perfect squares either.
5 and 8.
Which one did you say, Julia?
4 and 20.
4 and 20. Why don't we do 4 and 20? 4 is a perfect square, right? So this is, that negative on the outside has to stay there.
You mean 40 and 2? You said 40 and 2.
4 times 20. Okay, what's the square root of 4? 2. What do you think I'm going to do with that negative? It's just going to multiply times 2. So that's negative 2 square root 20. Can I break down the square root of 20 anymore? I can. How can I break that up? 5 and 4. And 4 is a perfect square, right? So this is equals negative 2 square root of 4 times 5. What is the square root of 4? 2. 2 times negative 2. We just multiply them together. Negative 4 root 5. That's my answer. I could have just gone straight to using 16 and 5. But that's okay, we can practice. So when we take out that 2 from the 4, we have to multiply it by the -2 outside. So make sure you don't forget that step. Okay? So far, so good? Yeah? Okay, example 3. Okay, this is something we have not seen yet. There's a variable inside the root. Okay. First of all, let's see if we can break down 28. Can you break down 28 using a perfect square? 4 and 7. So this would be the square root of 4 times 7 times n squared. Okay, what perfect squares are in here? 4 and? Is n squared a perfect square? It is. What's the square root of 4? 2. And what's the square root of n squared? N. So on the outside is 2n. And what's left inside? Just a 7. Okay with that? Okay. Question before we move on to the next few examples. What if I gave you a problem that said the square root of x to the third? What if I gave you a problem that said square root of x to the third? Can you rewrite x to the third using a perfect square? X squared times x. So what would this simplified be? X root x. So was x to the fourth a perfect square? It is. What's the square root of x to the fourth? X squared. Yep. Okay. So break it down into even numbers is what you want to do. Okay, example 4. Now we're actually multiplying these things. Square root of 10 times square root of 40. Step 1 said to multiply the outside of the radicals. Is there anything outside to multiply?
No.
No. So we're going to go straight to multiplying the inside. So this is the same as the square root of 10 times 40, which is the square root of 400. Now I need to simplify this. Can you rewrite 400 using perfect squares? 200 is not a perfect square. 20, 4 and 100 works. 20 times 20 could work, right? So let's look at it. This is the same. I'm going to use 4 and 100. 100 times 4. What's the square root of 100? 10 times, what's the square root of 4? 2. 10 times 2 is? 20. Brooke also made a good point. 400 itself is a perfect square, 20 times 20. So you could have just recognized that right off the bat and taken the square root of 400 to get 20. Okay? You can do it either way. So you could go straight from here to equals 20 if you want. Okay, example 5. 2 square root 22 times 3 square root 11. First I need to multiply the two outside numbers. 2 times 3 gives me 6. Square root of 22 times 11, which is 6 square root 242. Okay. Can we break down 242 using a perfect square? 121 times 2. So this is the same as 6 square root 121 times 2. Six times, what's the square root of 121? 11. So 6 times 11, square root, what's left inside? 2. And what's 6 times 11? 66 root 2. Okay, example 6. Is there anything to multiply outside? No, so I'm going to go straight to multiplying the inside. This is square root 3 times 51 times x to the third. So all I did was I reordered my numbers and my x's so they were all next to each other. Okay. What is 3 times 51? 153. X times x to the third. X to the fourth. Good. Okay. Can I rewrite 153 using a perfect square?
No.
You can. 17 times 9 times x to the fourth. Okay, let's look at this. Square root of 9 is what? 3. What's the square root of x to the fourth? X to the second. So 3x squared is on the outside. What's left inside? 17. Good. And that's it. Before I let you go, really quick, what is the square root of x to the 6th? 17. X to the third. Okay. How many x squareds do I have in there? This is the same as x squared times x squared times x squared. X times x times x, x to the third. Okay, so it's just half of whatever your exponent is. Okay?